If you've been thinking about buying a new graphics card lately, don't! At least that's what half the internet is saying because of a clever little program that will double your current GPU frame rate. Not really, but Lossless Scaling is an impressive program nonetheless, which allows you to run AI frame generation on any graphics card to dramatically improve the smoothness of any game that you play. But does it actually work, and who exactly should be using it? Welcome back to Craft Computing, everyone. As always, I'm Jeff. Lossless Scaling is a program that's actually been around for quite some time. Originally intended as a resolution scaler, hence the name Lossless Scaling, it was able to take games running at low resolutions, say 720p, and apply sharpening techniques to make the game appear at 1080p, all without having to worry about your monitor scaling a non-native resolution. I've actually been toying with the app since 2019 in various forms, because it worked well for what it did. But there is a new feature that caught the attention of budget gamers everywhere, and that's the addition of AI frame generation for basically any graphics card that you own. Basically, you can fire up the app, fire up your game of choice, and then activate AI frame generation with a simple key press. Using your graphics card, Lossless Scaling will look at the frames being generated by the game and utilizes AI to generate frames in between them, essentially doubling the output frame rate. The result is somewhere between being acceptable and downright amazing, depending on the game that you play, and your own sensitivity to artifacts from AI-generated frames. It's definitely not perfect, but when your choices are to play at 45 frames per second natively, or at 85 frames per second with minimal loss in quality, it's not hard to see why some gamers are starting to swear by running lossless scaling on their rigs. All that being said, it's definitely not for everyone, not for every bit of hardware, or even every game. In this video, we're going to take a look at quite a few different configurations, games, and some hot opinions from me to see if you should run lossless scaling in your gaming PC. First off, let's start off with your GPU. What hardware are you running? Will it work with lossless scaling? And more importantly, should you run lossless scaling? Officially, there is no minimum requirement to run lossless scaling or its AI frame generation. And while that's technically correct, if you plan on running frame generation, I would take note of the recommended requirements for your GPU. And that is an NVIDIA RTX 3000 series or higher, an AMD Radeon RX 6000 series or higher, or an Intel Arc-based GPU. Frame generation will technically work with older GPUs, but it's definitely not optimized for older architectures, and it requires a metric ton of GPU compute power to make happen. It essentially would draw GPU power away from your game in order to draw fake frames, and would likely result in your GPU being able to run a game at, say, 60 frames per second natively, but then by enabling frame generation, it would consume 50% of your GPU resources, running the game internally at 30 frames per second. Also, it can output a massive improvement of 60 frames per second. You see the problem? So you're going to want a relatively modern GPU to run frame generation, or at least something from the current decade. I've done some of my testing today with an RTX 3050, and in Cyberpunk, with settings at 1080p and RTX medium presets, we hover between 35 and 40 FPS when rendering natively. However, enabling lossless scaling frame gen, we're able to creep into the mid-60s. Most people critical of frame generation will be quick to point out here that the frames being generated aren't real, and the game is still only responding at the speed it's natively rendering frames at, closer to 35 frames per second. And yes, the input latency of Cyberpunk with frame gen at 65 FPS is the same as the input latency of a game running at 35 FPS. Do you know who cares about that? Only people who are already playing the game on high-end GPUs in the first place. While the latency isn't as good as running the game natively at 65 frames per second, it's no worse than playing the game at 35 frames per second. But the perceived smoothness is far and away a better overall experience. And if running a smoother game gives you more immersion and a better time when playing, it's 100% worth it to enable frame gen. But now let me swing the other way with what will probably be a slightly controversial opinion. If you have a high-end GPU from the last 6 years, that means something around a Radeon 6800 or an RTX 3080 when it comes to performance, you likely don't need lossless scaling. At least most of the time, you're not going to. If you've spent any amount of money on a graphics card in the last 6 years, you likely also purchased a high frame rate monitor. They've been affordable enough to be able to snag a 1080p 144Hz panel for just over $100, or 1440p panels are regularly available below $200. If you have, let's say, an RTX 3080, and you're already getting 120 frames per second in nearly every game at 1440p and ultra settings, there's absolutely no point to running frame gen on that monitor. 60 frames per second means frames are being displayed every 16.7 milliseconds. Doubling that to 120 frames per second means that frames are delivered twice as fast, at 8.3 milliseconds each. 144 frames per second is 6.9 milliseconds per frame. Nice. 240 FPS, topping out any monitor under $500, gives you a new frame every 4.2 milliseconds. Those numbers say one thing blaringly loud to me. While faster is usually better, there are diminishing returns when you go past 120 frames per second. There's just not that much of a difference between 4 and 7 milliseconds when it comes to reaction time, and even less when it comes to perceived smoothness. While I'm absolutely sure that the top 3% of competitive esports players need that kind of speed, most of us don't. And along that same line, you also shouldn't run frame generation if you're playing competitive multiplayer games like Twitch shooters. It's better to switch all of your settings to low to improve frame rates than to deal with visual anomalies and increased latency that may make your gameplay worse. On top of that, most programs that display overlays in games are banned anyway, so likely not a great idea to run lossless scaling in multiplayer competitive shooters in the first place. You really get the best results out of lossless scaling if your PC is running games somewhere between 45 and 75 frames per second natively. So, what does that look like? Let's take a look at lossless scaling doing what it does best, taking an older gaming PC and making it feel brand new. I decided to test on one of my X99 rigs with an Intel Xeon E5 2687W-V4 12-core workstation CPU. And for GPUs, I've got an RTX 3050 8GB, an RTX 3070, and an AMD RX 6700 XT. The RTX 3050 is obviously a low-end GPU, and struggles at higher detail settings in basically every game. It's a great card for gaming at 1080p 60 frames per second, but not much beyond that, making it a perfect candidate for frame generation and lossless scaling. The other two cards are both around 5 years old at this point, and mid-tier when they were released. At 1440p, can they still hang with modern titles, or could they use a little bit of a helping hand? For AI frame gen, there are multiple settings that you can tweak, but I found the best results came with either a simple 2x multiplier, where lossless scaling will double the frame rate of your games, or setting a target of your monitor's refresh rate. Both have their pros and cons, with more frames being generated giving you more visual anomalies, so you can tune the settings to your own liking. Today we're going to be just running at a basic 2x multiplier, which is the default in lossless scaling. Starting with the RTX 3050, I already mentioned Cyberpunk earlier in this video. While you can play the game at 1080p low settings and no ray tracing and get nearly 90 frames per second out of this graphics card, that also makes for a pretty terrible experience. Because there was so much work put into ray tracing effects, simulated reflections have some major issues in this game. But enabling ray tracing and medium settings means the RTX 3050 can barely hit 40 frames per second. With lossless scaling frame gen, we're able to jump from 40 FPS all the way up to around 70 FPS on average with ray tracing enabled. There is a performance penalty for running frame gen, but the output is still significantly faster than native rendering, even on a card like the RTX 3050. I did go ahead and attempt setting a constant 90 FPS in this title as well, just to demonstrate a worst case scenario. And honestly, the results aren't that bad. It amounts to basically a 3x ratio, or 1 real frame for every 2 generated frames. There are some strange visual anomalies, mostly relating to shadows cast by your weapon, but overall, it's pretty minor and an incredibly smooth experience overall. Kingdom Come: Deliverance II was an insanely demanding title on release, but has benefited from some performance improvements via updates over the first couple of months. Now the RTX 3050 can run the game at 1080p and medium settings, and manages to hold around 85 frames per second on average. This is one example of a game that, even running on low-end hardware like the RTX 3050, I wouldn't bother enabling frame gen. The return in generated frames just isn't that much better than rendering the game natively. Again, frame gen does come with a performance hit to native rendering, and in Kingdom Come: Deliverance 2, it drops you from around 85 FPS down to around 60 FPS. While the game still hovers at around 115 to 120 frames per second with generation enabled, the leap from 85 FPS native to 120 FPS AI generated isn't the market improvement that you might expect, especially in what is just a single-player game. And one more game that I ran was the Elder Scrolls Oblivion Remaster. The original game might be running code from 2007, but just like when it was new, cranking up the graphics settings can bring even modern flagship GPUs down to their knees. At 1080p, low settings, and with hardware ray tracing set to low, we see an average of around 60 frames per second. And honestly, despite the low settings, the game still looks decent enough. Not great, mind you, but decent. Enabling lossless scaling frame gen drops our native performance by around 25%, giving us an average of 45 frames per second natively, with a scaled output to 90 frames per second. That's around 50% faster AI generated than it is native, and makes for a much smoother experience overall. And unlike Cyberpunk, there weren't any obvious signs or anomalies to speak of. Moving on then to the other two graphics cards, and I'll start with this note. I didn't want to compare the 3050 against the 3070 or 6700 XT in an apples-to-apples test. This isn't about which graphics card is fastest. This test is specifically about running lossless scaling on a graphics card you might own and what your experience might be. If you have a mid-tier GPU, you're not going to be running titles at low settings or even 1080p. You're likely running at 1440p and have details trending towards high, and that's exactly how I tested these two cards. Cyberpunk at 1440p and ray tracing set to ultra is challenging for any GPU, and even more so on mid-tier GPUs from 2020. While the 3070 managed to come close to 45 frames per second natively rendered, the 6700 XT struggled hard here with its first-gen ray tracing from AMD and managed only around 35 frames per second on average. Demanding games like this are again a perfect scenario for AI frame generation, taking a title that is on the fringes of playability and making it an actual enjoyable experience. With lossless scaling, we see a jump from around 50 FPS to north of 80 FPS on the RTX 3070. And shockingly enough, the 6700 XT wasn't too far behind, hitting 70 FPS with FrameGen enabled. With Kingdom Come Deliverance 2, it's a similar story, with the 3070 again hitting just shy of 60 frames per second, and the 6700 XT closer to 48 frames per second. While both cards are able to play the game at 1440p and ultra settings, both also can't sustain a smooth 60 frames per second on average. And while you absolutely could run the game at high settings and make up the difference, turning on FrameGen through lossless scaling allows you to keep a higher resolution and texture, as well as the higher resolution geometry, making the game a better overall experience, as well as having a much smoother frame rate. With FrameGen enabled, we get similar results to Cyberpunk, around 95 frames per second on average for the RTX 3070, and somewhere in the low to mid 80s on the 6700 XT. And while in Cyberpunk there were some graphical issues, one of the main reasons they were so obvious was because of the bright colors and high contrast in that game. In Kingdom Come 2, a bit of ghosting around your weapon or fast-moving objects, it's a bit less obvious because of the more muted color palette. And if I had a high refresh rate monitor, I would absolutely enable FrameGen on this one to smooth out the native stuttery frame rate. And finally, Oblivion. If you thought the RTX 3050 struggled at 1080p and low settings, buckle up, because this is where things get worse on both of these cards. We're running at 1440p high settings, along with high on the hardware ray tracing. The RTX 3070 with NVIDIA's 2nd gen RT cores struggled quite a bit with this one, averaging just 37 frames per second. Strangely, it's the 6700 XT here that fares better at the same settings, coming in closer to 52 frames per second on average when rendering natively. A result that's so weird, I checked it twice. With lossless scaling enabled, that number jumps up to 94 FPS on the 6700 XT, meaning there was also very little drop-off in performance from rendering the game natively. The RTX 3070 also sees basically no drop-off when enabling FrameGen, holding its 37 FPS average natively and running at 74 FPS with FrameGen enabled. And again, I really don't recommend lossless scaling FrameGen if you're already running games between 90 and 120 FPS already. For starters, high refresh rate monitors above 144 Hz are still on the expensive side of things, and running faster than your monitor can display really doesn't do you any good. But if you're struggling to even hit 60 frames a second, being able to effortlessly run your games at closer to 90 or 100 frames per second is going to make a night and day difference for a lot of people. But that's not all that's exciting about lossless scaling. See, while there is a performance hit for running FrameGen on the GPU that's rendering your game, lossless scaling also has the ability to use a second GPU for FrameGen, while your primary GPU renders the game itself. That's right, dual GPU may be back on the table. In the 3 games that I tested here, they all showed some performance loss when scaling from FrameGen, anywhere from 10 to 30% depending on the game. That's not a terrible trade-off if your game runs natively at 60 frames per second. Even if you see a 25% hit to native performance, that lands you at 45 FPS, which doubling that up gets you 90 FPS for the final output. And that is still a win in my opinion. But by running a second GPU, you could enable frame gen with zero performance loss, and not only double your frame rate, but possibly push things even higher if you wanted. So I tried it out, running the RTX 3050 as a dedicated frame gen card, with the RTX 3070 and RX 6700 XT rendering the games. And in the 3 games I tested, came up with some pretty mixed results. See, to enable a second GPU for frame gen, your PC needs to be set up in a specific way. First, you need to be able to install a second graphics card in your PC. Not a guarantee with limited PCIe lanes on desktop hardware these days, and part of the reason I opted to go with an X99 rig. But even a PC with an extra PCI Express X4 slot should do the trick, as you're not using a whole lot of bandwidth to your frame generation card. Next, the second GPU is what you plug your monitor into. So in this case, I have my monitor connected to the RTX 3050 and nothing plugged into the RTX 3070. Next, in Windows, go to Display Settings, Graphics, and then Default High Power GPU, and select the faster of your 2 graphics cards, in this case, the RTX 3070. Then inside Lossless Scaling, we need to tell it what the preferred GPU is for processing frame generation, so in my case, the RTX 3050. In theory, whenever you launch a game, the RTX 3070 will render the game, and then copy the frame buffer over to the RTX 3050, where it will then be pushed out to your monitor. And this should work around 90% of the time. However, in the 3 games that I tested with the RTX 3070 and the RTX 3050, Cyberpunk was the only game that was happy with this whole arrangement. Getting into Cyberpunk, we can see that the RTX 3070 is handling the rendering, with the RTX 3050 sitting at around 25% utilization, just displaying the game. And we're running at around the same 47 to 50 frames per second as our initial test on the RTX 3070. So far, so good. Enabling lossless frame gen, we see no change to the rasterized frame rate, sticking right around 45 frames per second. But we do see the utilization on the RTX 3050 climb to around 40%, with frame gen reporting around 90 frames per second, a 10 FPS improvement from running on a single card. I'm not sure a 12% boost in the final frame rate is worth the added complexity, but that being said, you can do more than double the frame generation on your frame generation card. You can do a 3, 4, or maybe even a 5x multiplier. And remember, none of that is going to impact the card that is rendering your game. All that workload is going to be pushed to your second card only. So the sky is the limit, but remember, there are diminishing returns the higher up that rate you go. But like I said, this is a much more complicated setup. On the RTX 3070, launching Kingdom Come 2 results in the game launching a black screen and loading the cursor, before immediately crashing back to the desktop, with no signs of life whatsoever, and nothing I tried was able to get the game to load. In Oblivion, I did get the game to load, and I got into the game just fine. The only problem was, it was rendering on the RTX 3050 instead of the faster RTX 3070. This is a problem I've ran into when using this feature in Windows before, and is a game-by-game issue. Some titles run just fine with rendering on a non-display card, some just don't. So the RTX 3070 is 1 for 3 for running games on the RTX 3070 and then running frame gen on the RTX 3050. Did the 6700 XT fare any better? In a word, kinda. See, this time, Cyberpunk was the one that decided it didn't want to launch, this time with a message about corrupt video drivers, despite me installing both drivers fresh multiple times and trying to run Cyberpunk multiple times. This game was just never happy, probably with the mismatch of AMD and Nvidia installed in the same system. Come to think of it, I'm a little shocked this PC hasn't just spontaneously combusted at this point. Kingdom Come 2? No notes, it ran absolutely perfectly. It launched, rendered on the 6700 XT, displayed out the RTX 3050, and ran at around 50 FPS natively. When enabling frame generation, it did exactly as expected. AI frame generating frames on the RTX 3050, and we got just over 100 FPS on average. Pretty solid result. Moving on to Oblivion, and again, this one just kind of worked as expected. Again, we got just shy of 55 frames per second natively on the 6700 XT, and we're able to climb well above 110 frames per second when pushing frame gen onto the RTX 3050. And just like Kingdom Come 2, while there are some artifacts of frame gen here and there, none of them really distracted from the gameplay in Oblivion. And in fact, I would rather play with frame gen enabled if it meant some visual artifacts, if it also means locking in the frame rate above 100 frames per second. So then, all of that kind of boiled down. Lossless scaling is a really cool piece of software. Like I mentioned, I've been using it for years for its original intended purpose. That is, scaling games rendered at non-native resolutions on LCDs so they can look better when playing them. You can also apply FSR or any number of other smoothing and scaling techniques to improve the visual quality in games that may not natively support it. But the addition of generic, hardware-agnostic frame generation tools means lossless scaling is a must-have for just about any gamer on a budget. I am also going to say that my jury is still out on whether or not to recommend lossless scaling when using multiple GPUs, as I have about a 50% success rate in this video. I can, though, definitely say I see use cases for pairing up two older GPUs to improve frame rates, or maybe using mining GPUs to render games and an inexpensive server GPU to output the video. In fact, I picked up a couple new server GPUs recently, like this AMD X080 mining card, so stay tuned for some content around this one very shortly. But as a tool for someone just wanting a bit more performance out of an aging PC, I think lossless scaling is absolutely worth the price of admission. It's only $7, and you can buy directly from Steam or directly from Lossless Scaling's website as a standalone application. I've got quite a few more tests that I want to run with lossless scaling, like installing it onto the Steam Deck and other gaming handhelds, seeing how it works in Linux, and like I mentioned, running it with GPUs with no native video output to see if I can give some server GPUs a new lease on life. Let me know what you want to see with the software, and I'll add it to my list. But that's going to do for me in today's video. If you like this one, make sure to hit that thumbs up button and subscribe to Craft Computing if you haven't done so already. Follow me on Blue Sky for daily shenanigans like this. And if you like the content you see on this channel and want to help support me in what I do, consider joining the Patreon. Link is also down in the video description. Thank you all so much for watching this one, and as always, I will see you in the next video. Cheers, everyone. Beer for today is from a growler. This is from... Good lord. I won't be having a beer today. The beer for today is going to remain a mystery to everyone involved. There we go. It's a good seal on that. Beer for today is a local beer, if you couldn't tell from the growler. This is from Santiam Brewing. It is their Spitfire IPA. Also, new 16-ounce can glasses coming soon with a brand new design. Not the circuit design, something else. Stay tuned. So, the cap of this one said Spitfire IPA. This is not their Spitfire IPA. This is their 1859 Maibock from Santiam Brewing. I had 3 growlers in the fridge. I think the caps got missed at one point. Anyway, 1859 is one of my favorite brews from them. It is so incredibly malty. It is this deep caramel amber ale Maibock that just goes so well with any food you could possibly ever pair it with. This is usually the beer that I will get when I go to the brewery and their pub house, and they have fish and chips, they've got gourmet burgers, they've got fries, they've got sides, they've got slaw, they've got English breakfasts there. This goes well with all of them. Anytime I have this beer by itself now, I start to get hungry, and it's a Pavlov response. I smell 1859, I taste 1859, there'd better be a burger or a giant stack of fish and chips that comes beside it. That's probably just me, but I like this one a lot.